During winter, you may have observed that the sun appears to be lower in the sky, resulting in shorter days and longer nights. This is due to the sun's position leaning towards the horizon rather than directly overhead. On 21st March and 23rd September, day and night are of equal length. However, at the poles, there are 6 consecutive months of daylight and 6 months of continuous darkness. The length of day and night varies with the season, which in turn depends on the Earth's position. According to the location of the planet, solar energy does not fall equally on all parts of the world. As a result, some regions have less winter intensity and some regions have more winter intensity, and some parts of the world are deserts. So buckle up, science enthusiasts, nature lovers, and curious minds of all ages. Get ready to explore the incredible phenomenon of season change on Earth. Today's video will mainly discuss about all these issues. Initially, it was assumed that because the Earth orbit around the Sun is elliptical and the Sun is not the center of the ellipse, summer occurs when the Earth comes closer to the Sun throughout its evolution. Winter is when the Earth is farthest from the Sun. So, it turns out that the seasons are not solely determined by the Earth's proximity to the Sun. When the Earth is closest to the Sun, known as perihelion, it occurs in January. But contrary to expectations, it's cold. Conversely, when the Earth is farthest from the Sun, called aphelion, in July, it's hot. Although the Earth's orbit is elliptical, the difference in distance between perihelion and aphelion is only 3%, making the Earth's orbit almost circular. Normally we think the Earth might be straight like this, but that's not really the case. The Earth is actually tilted on its axis by 23.5 degrees, which is why globes are made with a 23.5 degree tilt. This tilt causes the sun's light to not hit all parts of the Earth with equal intensity as the Earth rotates around the Sun. This variation in light intensity is the main reason for the seasonal changes on Earth. Here is the position of the Earth and the Sun in December. Note here that the northern hemisphere of the Earth is tilted towards the opposite side of the Sun. As a result, as you move from the equator to the northern hemisphere, the length of the day will be shorter and the light will fall diagonally. As a result, the intensity of winter increases northward from the equator. How sunlight hits the Earth plays an important role in the severity of winter. Think of a flashlight to illustrate this concept. When the light from a flashlight hits a surface perpendicularly, all the energy is concentrated on a small area, causing it to heat up the most. However, if the light hits the surface at an angle instead of straight on, the same amount of energy is spread over a large area, resulting in less heating. Exactly the same happens in December. As day length decreases northward from the equator, solar energy becomes less abundant, resulting in winter. Now in this situation, if you look towards the southern hemisphere, then you will notice that the length of day is longer and the length of night is shorter. Also, light falls relatively perpendicularly, resulting in summer there. Thus the position of the Earth and the Sun in March will be like this. Here the Earth is tilted in the same direction as before by 23.5 degrees. But this tilt is not toward the Sun or against the Sun, so that at this time, the length of night and day on Earth are equal. This also changes the incidence of light rays, resulting in seasonal changes in the northern and southern hemisphere. Thus, if we consider the case of June, then the Earth will be tilted in the same direction as before. Now, since the tilt has not changed its direction, this time the northern hemisphere is tilted toward the Sun, in which case the days are longer and the nights shorter in the northern hemisphere. During this period, summer prevails in the northern hemisphere and winter in the southern hemisphere. Thus in September, again the length of day and night are equal. Now, if the Earth was not tilted on its axis when revolving around the Sun, then the seasonal variations would not be seen on the Earth. Note one thing here, due to the tilt of the Earth, the northern hemisphere faces the Sun for about 6 months, and the remaining 6 months are opposite to the Sun. That is, the light does not reach the northern hemisphere for 6 consecutive months, and the light reaches for 6 consecutive months. In such a case, the question may come to the mind of many people. Since there are days in the pole for 6 consecutive months, then why the ice there does not melt? Although there are 6 months of continuous daylight at the poles, sunlight hits them at a very oblique angle, resulting in minimal heat reaching the poles, which is insufficient to melt the ice. The Sun at the pole is basically tilted towards the horizon. If we look at the position of the Sun at the pole for 6 consecutive months, it will look like this. Some places of the world are so dry that there is no rain at all. We can call those places deserts. Deserts can basically be divided into 4 parts: the hot and dry deserts, rain shadow deserts, coastal deserts, and polar deserts. The hot and dry deserts are mainly seen in subtropical regions, i.e., Tropic of Cancer and the Tropic of Capricorn. Hot and dry deserts are seen in these regions. In these areas, sunlight falls perpendicularly at certain times of the year. The air in this region has virtually no moisture or water vapor, so clouds cannot form in this region, resulting in very little rain, resulting in deserts. Rain shadow desert is mainly made for big mountains. These high mountains block the clouds on one side, causing one side to get lot of rain and the other side to receive very little, turning it into a desert. This is the case with the Atlas Mountains north of the Sahara Desert. Another example is that Atacama Desert, known as the driest desert in the world, which receives only 15 millimeters of rain per year. The big deserts of the world basically belong to these 2 categories. In deserts, there can be a significant difference between daytime and nighttime temperatures. For example, temperatures can soar to 15 degrees Celsius during the day and drop to as low as -4 degrees Celsius at night. This temperature variation is due to the unique characteristics of desert environments. During the day, the desert sand absorbs sunlight and heat energy, causing the sand to become very hot. However, the sand does not retain much of this heat, so at night it releases the stored heat energy, warming the desert air and contributing to extremely high daytime temperatures. Conversely, at night when the sand releases heat energy, there is minimal water vapor in the desert air to retain this heat. Water vapor has the ability to hold heat effectively, but with very little water vapor in the desert air and no clouds in the sky, the desert cools down rapidly at night as there is nothing to hold the heat energy released by the sand. Desert may seem unimportant to many of you, but that's not entirely true. The Sahara Desert is the largest desert on Earth. In 2006, NASA's Calypso satellite observed that the Sahara Desert plays an important role in supporting the Amazon jungle. Data collected from the satellite from 2007 to 2013 showed that on average, 182 million tons of dust particles were blown westward from the Sahara each year, with about 27 million tons of these particles falling into the Amazon jungle. These dust particles from the Sahara contain phosphorus, a vital mineral essential for the nutrition of the Amazon forest trees. In tropical regions like the Amazon, phosphorus deficiency is common due to the flooding and other factors. Without the dust from the Sahara, the Amazon might not have been as flourishing as it is. It's incredible to think about where all the phosphorus in the Sahara sand comes from, isn't it? The Sahara wasn't always a desert, and the transition from a green, lush environment to a desert must have been a quite journey. It's amazing to consider how everything in the world is connected in some way or another, and understanding those connections is what knowledge is all about. Perpetual motion refers to an object that stays in motion without requiring any external energy. Many people believe that free energy can be obtained from the perpetual motion. As a result, achieving perpetual motion has become a lifelong pursuit for many. Do you want to learn more about perpetual motion and whether it is achievable? Watch this video to gain a better understanding. And if you like the video, you can subscribe to our channel.